In this example, I've got two data sets. One particular data set has coordinates attached to it and the other doesn't. And what I want to be able to do is to compare the two. So to be able to do that, I need to make sure that I get the same coordinates into my image that doesn't have any in the first place. And this process is called georeferencing. So first up, I'm going to open the two images that I have. So these are both Landsat 8 images of the Cairns region. So one having those coordinates and one without. So we come up with an error in the first place, and this is just telling us that one of the images is missing spatial reference information, which is what we know, and that's what I'm going to fix here. And so that error is okay. So we have our two images that have appeared in the table of contents over on the left-hand side here. We can see one image up the top and not quite sure where the other image is. So let's go in first of all and have a look. So let's have a look at the non-georeferenced image in the first place. So if I right click on that and go zoom to layer, this is my image here that doesn't have the correct coordinates attached to it. So although you'll see numbers in the bottom right here as I wave my cursor around, they're not actual real map units and it doesn't know where it is in space. Now when I go across to my other image and zoom to that one, once again, as I move my cursor around, you can see those coordinates in the lower right, and I know that these coordinates are actually correct and I'll be able to find my place in space. So what I want to be able to do is to bring the other image on top of that so I can make some comparisons. So the first thing that I'm going to do is to activate the georeferencing toolbar. So if I right click in the toolbar area and click georeferencing, you'll see that I've got this new toolbar that's come up here. Now, what it's first of all asking is what layer am I going to georeference, and you need to make sure that you're selecting the correct layer there. And so for me, that's the non-geo image. So that's cool to start with. Now the next thing that I want to do is just to get the non-georeferenced image in the ballpark area, I'm going to use the georeferencing pull down and say fit to display. So that's going to fit my non-georeferenced image into this display area here, which is great. So I've now got it roughly in the ballpark area, so it will be a lot easier for me to find control points that match my two images. Now if I right click once again in the toolbar area, I want to bring up the effects toolbar. So what this is going to allow me to do is to interactively compare my two layers. So it'll make sure that I have the layer that's on top is the one that I'm going to apply the effect to. So I've got my sub non-geo image here on top, and I'm going to actually swipe that over the other one. So if I use that swipe tool, and you'll see that just like drawing a curtain, I can look from one image to the other. So the images are definitely not aligned at this point, but that's okay because that's exactly what we're going to fix. So the first thing that we need to be able to do is to find some features that we can identify in both images, the one with the coordinates and the one without. And it's important that when we pick these features, that they're the type of features that don't change. So it's no good picking a cloud in one image and trying to find that in the next image. That's not a very good control point at all. Sometimes crop boundaries can also be highly changeable, so we don't want to pick those either. So we're looking for really dominant features in the environment that are not changing over the period of time that we've collected our data. So that might mean some major road intersections, railway crossings, that sort of thing. So we want to zoom into the image and find those control points. So the first one that I'm going to pick, I know, is down in this bottom left-hand corner here. So I've found a point. This particular road intersection is what I'm going to start with. So in the georeferencing toolbar, I click my add control points little tool here. So once I click that once, and I click on that point that I've found in my non-georeferenced image. Now the easiest thing to do here is then to turn that one off so I can see my other image, and I want to now zoom in to where I can find that same spot on my referenced image. So once I find my feature, I click back on the control points tool and click on the feature that I've seen. Now once I've selected my two control points, the one on the on the image that doesn't have any referencing points and the image that does, I can zoom back out, and you'll be able to see that the images have slightly aligned to each other. So if I go back to my effects toolbar and I want to swipe one image across the other, it's not perfect yet, but it's a little bit closer than it was. So in that same way, we're going to go through collecting a number of different control points until we get the images nicely aligned and sitting on top of each other. Now, if at any stage you pick a control point that you're not happy with, you can simply go up to this View Link Table button, highlight the point that you've got there, and just hit delete, and that will allow you to remove that point that you've checked. So now I've moved on to create a number of ground control points across my image. So you can see that what I've tried to do is to spread those out across the image as much as possible. And rather than having a cluster of them in one small area, for example, which would mean that my transformation might be good in that area, but across other areas of the image it may not be very good at all. So I've spread them out to try and help that transformation work for me. Now this particular image is rather challenging because what I really want to do is to get those stable ground control points, and I can find several of them easily enough on the land area, but certainly in the water area that's really challenging, and even in parts of the reef, if there's no exposed land, that's really difficult as well. But so what I'm doing here is just for demonstration purposes, so you can get the idea of actually what's required. So if I bring up my link table now, you can see that I have quite a few points listed here, and you can see that it's also started to create these residual errors that you can see as well. So now this is going to give me an indication of how well the model fits where I've put my ground control points. Now what you want is for your residual error to be less than half a pixel. So for the Landsat 8 imagery that I'm using with a pixel size of 30 meters, I really want to bring that down to about 15 meters or so. So now I can go through and have a look at the individual ground control points that I've selected, and perhaps go back and see, do I need to move some of those to give me a better transformation, or maybe even some of them need to be deleted altogether. So you go through and have a look at the ones with high residual error. For example, that very first one that I selected might be something that I want to remove. Now if you have a look at the total error here at 80, if I was to remove this particular one here, you'll see them all change, because that's what happens as the model tries to refit. So if we delete that one out, you'll see that that brings my overall error back down to being within my acceptable less than half a pixel. You do have to be a little bit careful when you're doing this to make sure that although your error might be low, you may have messed up the model so that a model fits, but it might be the wrong model. So you always need to go back and check that your image hasn't flipped upside down or something when you've done that. So if I want to check my two images there, I go back to the effects toolbar, and you see as I swipe from one layer to the next, at least at this scale, it looks like a fairly decent match. Now what we actually want to do is then to zoom in a lot closer and check particular features and look how well our model is actually fitting our data there. Now you can also play around with the transformation. So as you can see here, this one's just using a first order polynomial at this stage, and I have a number of other options. And the more points that I select, the more options will become available to me in terms of fitting that model. So you can go through and play with what happens when you change a model in terms of your error, and you can see that go up or down depending on the type of transformation that you've selected and how that's going to fit your data. So when you're collecting these ground control points, the next thing that you really need to make sure that you do is to save. So you can save these ground control points. If your project crashes for whatever reason, you can always bring them up again and then reapply the transformation to finalize your georeferencing, if that's what you need to do. So you can kill that table and it doesn't make you lose your points at all. It just pops them out of sight. Then when you're ready to actually perform the transformation, all you need to do is to simply go to rectify. So once you do that, that will allow you to select your output file and the type of resampling that you're interested in using. So at the moment it's got a default type of nearest neighbor, but you can also use the bilinear interpolation or cubic convolution, which is going to average a number of pixels around the point where you've actually selected it. So if you test out the different types of resampling, have a look at the effect on your data. But just remember that you shouldn't use the interpolated method, so either the bilinear interpolation or the cubic convolution, if you've got discrete data. So if you're resampling a land cover classification, for example, you need to be using nearest neighbor. So when you're ready to perform the transformation, you just select your output file and run that, and then you can bring it back in to overlay your original data set and then continue on with any analysis that you're ready to do, for example, a change detection.